Okay, so we saw a little bit about ellipses in class today, kind of based on it being like almost like a circle that's stretched, right? So now what I want to do is look at another property of ellipses in that they have two focal points, okay? And by a locus definition, the set of all points whose sum is a fixed distance from those 2 points, right? Those points would form an ellipse. And so you can see in the picture here, you do have like a point here and a point here, which is the focus. And if you pick any point on the ellipse, let's say I pick this point right here, and you measure this distance and this distance, right? Whatever that distance is, it's going to be the same no matter where you're at on the ellipse. So like maybe over here, like that distance plus this distance is the same, right? Or even if you're down here, if you measure this distance and this distance, right? It's the same. So that's another definition of how you get an ellipse, is that it's a set of all points whose sum of distances from two fixed points called foci is constant. Now, there are a couple different things that we've already talked about in terms of like important pieces of ellipses. Like we know that the major axis is 2a. And so, if we think about the distance from the center, from the center to, there we go, pen, from the center to the edge there, that distance there we say is A. And we already know that the minor axis is 2b. So the distance from here, center, up here is b. And what we're going to do is we're also going to get a focal distance. And that distance is from the center to the foci, or one focus. And that distance will be c. So we have A being the distance from the center to the focus. We have B being the distance from the center to the minor axis. And then C is from the center to the focal point. Now, there's actually a relationship here that exists between, or I should say among all three variables. And it's based on the Pythagorean theorem. Just watch your letters because A has to be the largest. It's b squared plus c squared equals a squared. And the way that this works actually is that so we obviously see this as c, we see this as b, and the thing is that if you actually look at the distance like here to here, that distance is actually equal to 2a, making this distance here a. So you get b squared plus c squared equals a squared. B squared plus c squared equals a squared. A lot of times, and more useful, is that c squared equals a squared minus b squared, because you would be given these two in your equation. For example, it says find the coordinates of the focal points in this, in these examples below. So the first thing I'm going to do is going to put it into standard form, which means I'm going to make this a 1. So I'm going to divide by 16, divide by 16, divide by 16, because we want that to be a 1. So we get x squared over 1 plus y squared over 16 equals 1. So I know that this is my a squared, this is my b squared, and if I were to have sketched this out, I know it's going to be more in the y direction than the x. So I would go 4 in the y, because the square root of 16 is 4. I'm going to go 1 in the x. So here's my ellipse. Okay. Then, because I know that c squared is equal to a squared minus b squared, I could just do 16 minus 1, which equals 15. So that means that c is equal to plus or minus root 15. So from the center, I'm going to go in the major axis direction. I'm going to go root 15 in this direction and root 15 in that direction. It's just an approximation of where that point is. So my focal points will be 0 plus or minus root 15. Cool. Okay, next. Here it's already in standard form. Notice, right, because I already have a 1 there. So I know it's not asking me to sketch it, but I think sometimes looking at it helps, the picture, I think. So then I know the center of this would be at -9, 7. So just a sketch sometimes helps. Right, so -9 up 7. And then in the x direction, I go 5. So I go out 5 in that direction, 5 in that direction. And then I'd go 3 in the y direction from the center. 3 and 3. So I draw my ellipse. And remember, we said the center was -9, 7 right there. Oops, I thought I picked a different color. There we go. -9, 7. Okay. So then we know that c squared equals a squared minus b squared. So 25 minus 9, which equals 16. So that means I'm going to go the square root of 16, because that was c squared. So I'm going to go the square root of 16, which is 4. Remember, you go in the major axis direction. So we're going to go 4 in this direction and 4 in this direction. So that -9 was the x component. So I'm going to add or subtract 4, right, going to the right and going to the left, 7. So what are those two? Well, -9 minus 4 would be -13, 7. And then if I add 4, that would be -5, 7. So those are my two focal points. Okay, let's do one more here in this, where it says, again, the center of this, I think it's helpful to sketch that. So we'll go -2, -1. Put that center right there. So center is -2, -1. Now, in the x direction, we're going to go at the square root of 4, which is 2. But in the y direction, we're going to go a little more than 3, right? Because the square root of 10 is a little more than 3. So maybe up here, maybe down there. And so we draw our ellipse. And we can calculate c squared. So c squared equals a squared minus b squared. So it's 10 minus 4. And then that's a nice thing, too, is like it's always going to be larger minus smaller to figure out what that is. So c squared is equal to 6, which means c is equal to plus or minus the square root of 6. I should probably put a plus or minus 4 there. Okay. And again, you go the distance of the major axes, which is, in this case, y, because 10 is under the y. It's the bigger one. So we go root 6 in this direction and root 6 in that direction to find our two focal points. And so then, again, going from the center, if the center was -2, -1, the root 6 is in the y direction. So we're going to be augmenting that -1. So one focal point. Oh, sorry. I don't know what just happened there. That's nice. Maybe later. Got it. Awesome. Give me back my... Where'd it go? I have no idea. Where'd it go? Where'd it go? Oh my goodness, how embarrassing. Okay, let's see. Where did this go? Escape this, close that. Okay, there it is. Sorry. I was like in tablet mode. I couldn't find my toolbar. Okay, okay, so almost done. So root 6, root 6. So I'm going to go root 6 in the y direction. So my center was, I just did it again. Shoot. Go back to this. Oh my gosh, this is so funny. Okay, I'm going to try to do this not in tablet mode then. Go away. That's my BC calculus. How embarrassing, right? All right, what a great video here. There it is. And so all I do is finish the example. Okay, root 6. So we're going to go root 6 in that direction and root 6 in that direction from -1. So it's -2, -1 plus root 6. And then it's going to be -2, -1 minus root 6. Okay, so I think I probably should stop the video here. And I'll make a second video that will look at example number 2, if you have a graph of it. And then also talking about eccentricity. Okay, so thank you for your patience on that video.